Assalamualaikum and hello everyone. Today we are going to present about trigonometry in architecture.
Hello everyone. I want to introduce our group member. The first one is Majdi, metric number 08 DEP 22F1136. Amirul, metric number 08 DEP 22F1112. Maria, metric number 08 DEP 22F1093. And the last one is Shaf, 08 DEP 22F1008. Basic history of trigonometry. The word trigonometry comes from the Greek words trigonon, triangle, and metron, to measure. Until about the 16th century, trigonometry was chiefly concerned with computing the numerical values of the missing parts of a triangle or any shape that can be dissected into triangles when the values of other parts were given. For example, if the length of two sides of a triangle and the measure of the enclosed angle are known, the third side and the two remaining angles can be calculated. Such calculations distinguish trigonometry from geometry, which mainly investigates qualitative relations. Of course, this distinction is not always absolute. The Pythagorean theorem, for example, is a statement about the length of the three sides in a right triangle and is thus quantitative in nature. Still, in its original form, trigonometry was by and large an offspring of geometry. It was not until the 16th century that the two became separate branches of mathematics.
Introduction of trigonometry. Trigonometry, as the name might suggest, is all about triangles. More specifically, trigonometry is about right-angle triangles where one of the internal angles is 90 degrees. Trigonometry is a system that helps us to work out missing or unknown side lengths or angles in a triangle.
Trigonometry in architecture.
Trigonometry in architecture. Trigonometry is used in architecture to ensure that buildings are built safely. Architects have to calculate exact angles of intersection for components of their structure to ensure stability and safety. Trigonometry used in architecture include arches, domes, suspension bridge. There are many uses of trigonometry in architecture, such as bridge, arch, ground, roof, and house.
So this is the trigonometry formula. Look at the first one. The triangle with adjacent side, opposite side, and hypotenuse. The formula is sin A equal to opposite side over hypotenuse. Cos A equal to adjacent side over hypotenuse. Tan A equal to opposite side over adjacent side. And we can look at the second. We can use the following formula like sin A equal to 1 over cosec A, or cosec A equal to 1 over sin A. Cos A equal to 1 over sec A, or secant A equal to 1 over cos A. Tan A equal to 1 over chord A, or chord A equal to 1 over tan A. Tan A equal to sin A over cos A. Chord A equal to cos A over sin A. So the last one is the formula of hypotenuse. So the AC as the hypotenuse equal to square root AB square plus BC square. We can replace the AB and BC to the number that have at the triangle. So AB change to 4 and BC change to 3. So square root 4 square plus 3 square. We plus it to get 25. And then square root 25, we calculate it to get 5 as the last answer.
Example of trigonometry equation in architecture.
Now, I will show you the example question that related to architecture. So, based on this question, we can see that we have to find the height and the hypotenuse of the building. To get the solution of this question, we will use tangent function. What is tangent function? Tangent function is tan theta equals to opposite over adjacent. Since we have the value of theta, which is 27 degree, and the value of adjacent, which is 45 meter, we can get this question by using simply algebra solution. The formula is tan theta equals to TB over SB. By put the value in, it will become tan 27 degree equals to TB over 45 meter. Before that, we have to use calculator to get the answer of tan 27 degree, and it will become 0.51. After that, we have to transfer 45 meter to the side, so it will become TB equals to 0.51 times 45 meter, and then we can get this TB equals to 22.95 meter. And then how we get the height of the building. So now I can get I have a bonus question by finding the hypotenuse of the building. So the formula for the to find the hypotenuse of the building is A square equals to B square plus C square. By put in the value, it will become x square equals to 45 square plus 22.95 square. Before we calculate it, we have to transfer the square of x square to the side, so that we can get the answer of x. And then it will become x equals to square root 45 square plus 22.95 square. Before we square root the 45 square plus 22.95 square, we have to calculate the inside of the square root, and then it will become x equals to square root 2551.703, and then we square root the 2000 plus 2551.703. It will become x equals to 5 meter 0.51 meter. 50 meter 0.51 meter.
Conclusion. We can conclude that without trigonometry, life would be much more difficult. Without going through the troubles, you can easily find something, so we think that it was a good invention by Archimedes, and thanks to this many architects need not go through the trouble to calculate things. So, it really helps in real-life application. Therefore, the concepts and techniques used in trigonometry must be understood and utilized not only in architecture, but also for daily use.